This is a standard up-armored, high-mobility, multi-purpose wheeled vehicle, commonly known as a Humvee. It's similar to those used in Iraq and Afghanistan. In the not-so-distant future, this Humvee could turn into something that looks like this. More than 320 horsepower, 24 inches of wheel travel, adjustable ride height suspension. This is the Combat Tactical Vehicle, or CTV. Although not slated for production, this technology demonstrator model may be the answer to the Marine Corps' wheeled vehicle needs.
The Marine Corps' efforts for CTV started in 2005 and was the preliminary efforts to come up with a replacement for the Humvee and evolved into what is now the Joint Light Tactical Vehicle program, being it's a joint program with the Army, and the Army's a lead service.
The CTV Tech Demonstrator is the product of what O&R had originally invested in about a year and a half ago. In 2005, the Marine Corps made a decision that they were going to try to replace Humvees with a more survivable platform, yet still be agile. So O&R saw that as an opportunity to get some quick technologies that had high levels of readiness already within them.
The CTV is the only member of the JLTV family to ever be built by the government. As the war on terror continues, there's a need for combat vehicles to include armor as part of its basic structure. The Humvee was not originally designed as an armored vehicle. As combat conditions around the world changed, add-on armor modifications were later made available.
The utilization of the Humvee in its current environment in the theater of operations requires it to be an armored vehicle. And when we actually put the armor on the vehicle to meet the protection requirements, it can no longer carry the payload, and then also the performance is affected because it was not originally designed to carry that much weight and still perform to the standards that are expected.
It was recognized that the threats changed a lot, and the old days of being able to just run up and down the highway or run some cross-country with a Humvee are gone.
The Marine Corps was responsible for leading the efforts and writing new requirements for a replacement vehicle. Building a technology demonstrator became the responsibility of the Nevada Automotive Test Center under contract to the Office of Naval Research.
We took those new requirements and went out to industry around the world. First of all, we went out and looked to see if there were any vehicles that already existed that could meet those requirements. And what we found was the answer was no.
A lot of it was specifications driven, trying to get a vehicle that could really help out the existing fleet. We didn't want to put a Band-Aid on certain existing vehicles.
We went out to industry literally around the world and developed a selection process to pick the best of the best for each of the components that would integrate into this system.
Since its construction, the CTV has undergone vigorous testing on different types of terrain. This is Susan's Bluff, one of the many vehicle evaluation courses at NATC in Carson City, Nevada.
Well, one of our terrains we have for the durability on a vehicle like this is cross-country and hilly cross-country. As you can see, this is hilly cross-country, and what we're doing here is we're really working on the mobility of the vehicle. You can see how it's rocking over a lot of the terrain, and the vehicle will slide over a lot of the loose surface on top, and that causes shock waves to go back through the drivetrain, and you'll get a reverse torque loading going downhill as opposed to when you're going uphill.
I think the thing to take into consideration is that when they designed the vehicle, those requirements were generated out of lessons learned, and as the scenarios changed both in Iraq and in Afghanistan, a lot of those lessons learned were incorporated in the requirements document, which fed into the basic design of that vehicle.
Soft soil mobility testing is conducted on sand dunes near Fallon Naval Air Station in Nevada. Both the Humvee and the CTV perform side by side.
Going over soft sand, you want a big fat tire, kind of like a snowshoe. That gives you better traction, really helps with the mobility of the vehicle. There's no free rides in the deep sand.
On this day, the Humvee couldn't make it up the hill. It was given a free ride.
So in terms of a head-to-head comparison, if we've got something going on at point A in the CTV, I can get more guys there faster and in better shape when we show up. And then if things really get bad, I can get out faster with more guys, and the survivability rate will be that much more.
Survivability has become one of the main issues facing any new vehicle design.
We, again, looked at various solutions, and we settled on a configuration utilizing ballistic aluminum. In developing this technology platform, we studied the blast pressure wave and the fragmentation that occurs from IED and mine blast and other events.
During a vehicle rollover, the force exerted on the vehicle's roof is dissipated throughout the hull. This provides protection to the occupants. The use of a V-shaped hull provides an equal level of protection during an IED event.
It means that the impulse from that event to the crew is substantially reduced. Unlike, say, a historic vehicle that might have a flat bottom.